So in this talk, I'm going to cover a few topics. So first of all, why the need to do this, which is really important because as you'll see, this comes at a cost. How can you do it? A live demo and also some conclusions as well. So first of all, about me, I've worked at a few different places in my time and I've seen a fair few things go bang in production. And whenever that happens, quite often when that happens, we have some kind of post-mortem, either a formal meeting or an informal chat. And what I find interesting about this is that for something to go bang in production and for the impact to be significantly large, it's never one thing that goes wrong. It's always multiple things that line up all together to make a perfect combination. And in the post-mortems, there's always multiple recommendations, which I just find really, really fascinating. And I really, really love hearing about other people's war stories of production incidents. So whenever anybody else joins the team, I'm always interested to know, where have they worked, what's gone bang for you in production. And as I say, there's never any one single thing that goes wrong. It's always multiple things, and to fix them, again, multiple recommendations. And as I think Fred Brooks said, there's no silver bullet. And I think that what I've got for you today, unfortunately, is not a silver bullet, but it can have value in some situations. So first of all, the question of why running acceptance tests in production is really significant because you'll see that this does come at a cost. It is hard. So first of all, before we go any further, Jamie Wilkinson from Google has a really good talk on monitoring, and he mentioned that it's a very, very big space and not everyone has the same definition. So you've got on the right-hand side of this diagram here the more proactive things, but then on the left you've got the reactive, I would say. So what this can really help with, and what I'm really interested in, is the failure detection and the incident response. There is also a little bit of, to do with business metrics, which we'll cover, but the main thing is the failure detection and incident response that this can help with. So I would argue that production incidents happen and are made worse because of gaps in between these two things. So signing off the build, let's assume that you have the best automated tests, the best test coverage in your build and deploy pipeline, and nothing gets released to production without it passing all of these tests. All of those tests are worthless if it's being deployed into an environment that is not working, and or an environment which doesn't meet the same assertions as what the build is expecting. So obviously we counter that by monitoring. My point is that the tests that infer that everything works on the CI servers become irrelevant if the monitoring and the environment is not up to scratch. So with most things in life, I suppose, and in technology, a lot of this comes down to cost-benefit analysis. So one of the things that I really, really love is these, what I would call standard health checks. And I think that they have a huge amount of value for a very low cost. If your app can't talk to application A or application B, you know that it's not going to be working. And an endpoint exposed on a web application that is called by some kind of monitoring framework that can report on this, I think has a huge amount of value and everyone should be doing it. Of course, you need to be able to respond to these things, and you need your monitoring and alerting to actually invoke into that. There's no point having the functionality if it's not going to be queried by monitoring tools. So you can use, obviously, Prometheus, which is a talk that I think I just missed, Dashing, and I really hesitated to write Nagios because I know that it's really sort of fallen out of favour. But the reason I included it was actually because this is where this came from, and it did work for us years ago. But anyway, there's a very good video on YouTube if you're interested by Andy Sykes, and it's actually called "Stop Using Nagios," and it's worth a watch. It's very sweary as well, but it's quite entertaining. So as I say, I really, really love these standard health checks, and so many issues are addressed or detected rather by having these health checks in place. Another thing that I like, so I'm a Java developer. I really like the Dropwizard framework because it actually berates you for not providing health checks. And you can see whenever you start up a Dropwizard app without any health checks, it will actually say, if this dies, you don't have any health checks, you're going to be letting your users down. It's almost like it's going on to say, you should feel bad about yourself for not doing this, which I really like it. It gets you into that mindset. So Of course, I think the best thing for monitoring is actually monitoring user or real client activity. The reason that this is so good is because everything else in the build process and the health checks as well are inferring that it should work. You know, if this test passes in the dev environment, and if this health check works in production, you know, production should be working okay. But of course, if you can track real user activity, you know it's working. You know that somebody's just signed in. You know that somebody's just bought a car or whatever it is your site does. So the cost-benefit analysis of this, I think, is very, very favourable. The key thing here, though, is can you alert? So the comment there, pretty graph, does it alert? I've seen developer teams with lovely widescreen TVs above their actual area with line graphs of user activity completely flatline, and it goes completely unnoticed. And these are the dev teams that are working on that actual system. So on the one hand, you know, how can that happen? You know, surely, you know, you need to be looking at this. But on the other hand, it's really understandable. Everyone's busy, and if it's not a clear green or red, there's no call to action. So situations where you can't alert, I think, are low traffic apps. A low traffic app doesn't necessarily mean that it's low value. You know, if no one has logged in, is the site broken, or is this just a slow day? You know, how do you alert? Even anomaly detection can only be so responsive if the sample data is so low. So I'd argue that build time tests, they can be used as monitoring. They have a lot of good things about them that lend themselves well to the monitoring space. They pass or fail. There's a clear action. This is not good, or this is good. They can have descriptive names, and they can also have helpful error messages as well, which can help incident response. It's really just that the motivation for writing tests is predominantly developers, you've broken the build, but it can quite easily be adjusted to, hey, engineers or ops, it's broken in production. You're just basically monitoring a different environment. So I would argue, with my Photoshop skills being pushed to absolute breaking point, that you can reduce the gap. I'm certainly not advocating that you run every test in production. That would likely be impossible or impractical. But by running some of them, you can reduce this gap. So the other benefit as well is if you have fantastic monitoring and alerting for your infrastructure, sometimes it's difficult to know the impact of an issue. So again, the dev teams that's working on that app in the middle, they know for sure that if it can't talk to app 1, that the product details functionality of that app is going to be completely broken, because they know that they're committing code to it day in, day out. But the people looking at that over the weekend and looking at that red X, how do they know what's the actual impact of this issue? And I think it's a common problem. You know something's wrong, but you don't know quite how bad it is. You don't know what the impact is. So at the bottom left here, you have an indication. Search results are fine, product summary is fine, but product details is broken. So you can tell the impact. Another benefit as well is supplementing a Canary release. I'm assuming that most people, did anyone want to put up their hand if they don't know what a Canary release is? Okay, so Canary release, you deploy your new version, but it's hidden. No one's using it. And then very gradually, you start adjusting the load balancer to just put a small percentage of the live user traffic onto that new version. So if it is completely ruined, you've only affected a small subset of your users. But a small percentage of a small number of users could probably equate to 0 over a day. So, and also the other point to remember as well is that they are still real users. So it could be good to run acceptance tests as monitors against that new version that's actually been deployed before it is even exposed to real users. Also, another benefit as well is real availability stats. So a funny story, we were using a SaaS provider, and we were calling their API, and they started returning us errors, and it caused us a production issue. And we went to their status page, and it was a sea of green ticks, just 10 by 10 grid of green ticks. And the joke was that this was just a static JPEG that they just served. And yeah, and even if it wasn't, how are they measuring availability? There is really no formal definition of availability and the site being available. People can cheat and can say, well, you know, the site's available if you can get to the homepage, but what about all those other features, that other functionality? So things like pingdom, which I don't know if you're aware of, they can ping your website and then they give you the availability stats. Rather than them owning that question of what is available, what is good, you can own that question. So pingdom can then call you run your acceptance tests and then report that status back. So the good thing about that is that you're being more honest about your availability, and you can also use that data as well to inform decisions on what architecture needs to be improved. You know, anecdotal things of, oh, that service is really flaky, become a lot more informed when you actually have statistics showing those errors over time. So, because of quite a few of those reasons, we were sold, and so, you know, we decided that we were going to do it. So this was a few years ago. This was when I was working at Financial Times, and we had Java code and we had Java tests, and the culture was we were very, very concerned about site reliability and availability. So the question then turned to, what's test? So we were on the membership team, and we decided that we were going to test just two very, very simple things. So logging in with the correct username and an incorrect one gets you the correct result. So we had to think about the test data. So we decided that we would just put a user in the database, we'd register with a really, really super descriptive email address, so that if this flags up on other systems and other reports, then they would work out, it's those idiots over in the membership team that are doing something dodgy on the production site, was our thinking. So how do we do it? The first thought was, well, these are tests, right? So let's just run them against production from our CI server. We decided not to do that. So the question here is, the CI server is probably going to be a dev box. You know, most places I've worked at, the Jenkins or the TeamCity box has got dev or -d in the host name. It's not monitored, and it's not supported as well as it is in production. So we thought, you know, it could work, but then at the weekends, the issue will be that, you know, there'll be a power down and people won't care because it's just dev, and then we'll lose all those benefits. So the next thought was, okay, well, we have Nagios running in production, and what we can do is we can just call our acceptance tests from Nagios. So that was really a bad idea, because Nagios relies on very, very quick, simple, quick-fire checks. That, you know, what's the hard disk, what's the CPU? You know, checks that return in less than 1 second. When you start running really long JUnit tests in Java, then you end up with a situation where Nagios is holding onto so many processes, and it's just kicking off more and more, and eventually the host just becomes unavailable. And also, we were deploying things in a very strange way. There wasn't anything else like that in our architecture, where we wanted to just deploy a few jars onto a server. So then the third thought that we had was, well, let's just treat it like any other microservice. We've got all of this cookie cutter code and stuff in our organization that helps us just write a new microservice and deploy it into production. Let's just take advantage of that and just bundle this up as a web app as we do everything else. So yeah, it's treated just the same. So my friend and I, we decided to write a library called Atom4j, which is acceptance tests as monitors for Java. And basically, the description is that this runs in a microservice. It runs all of your tests on a loop. You configure which tests it runs. It fires against your app, and it exposes a health check endpoint in just the same way. So Prometheus and dashing. So Prometheus I'll talk about later on. But yeah, this can be hooked up and monitored in exactly the same way as your other applications. But there are three big issues. So the first one is really the data. The data that is generated by the tests and the data that the tests need mustn't pollute or get in the way of things adversely. The events as well, how significant is the action? Viewing the homepage is not that significant an action. Buying a car is a significant action. Which ones do you do? How real do you want this to be are all the questions that you need to answer. And also technically, how and where will they run? So without further ado, it is now demo time. So I will see if I can get this set up. Okay, so another thing about me is that I like planes. So any excuse to build a website that has anything to do with planes, and I'm there. The reason that I thought this would be a good demo website, this is obviously hypothetical, is that this is low traffic, but it is also high value. So when you go onto the hotel booking websites and they pop up these annoying messages that say, hurry, 1,000 people have booked a hotel within this region within the last one day. Well, I went onto a plane selling website. Things like this do actually exist. You can go up there and buy a plane. And there are pop-ups that say, hurry, 20 people have bought a plane within the last 1 month. So, that was interesting, and it just kind of revealed the transactions and just the number of transactions per minute is obviously incredibly low. So this website, let's just go through it. I also have to give thanks as well to Jonathan Rankin, a fellow plane geek, who provided me with the photos. We have a homepage here, which is just very simple. We just got 2 buttons, search for Boeing or search for Airbus. You have search results, and if you contact the seller and say, nice plane, I want it, and then I'll leave my phone number, and then I can contact the seller. So then when I submit that, it should go off to the back end and then send a real email to the seller. So I haven't actually built the email sending, but what I have done is build a business leads API, which would obviously be just internal or secured, which I have not done at the moment. That's just completely public. But you can see my message, and you can see that would have been sent to the real seller. So this is not exposed on the website, but this has been sent through. So the other thing to mention about this website is that you could almost think of it as 2 separate services, because what I've got the static HTML, which is quite easy to serve, and then we also have the backend API, which is actually reading off of the database. So if I just inspect this page here and go to the network tab, reload the page, we should see some nice AJAX requests being kicked off from the client that come back. So I'll just show you those in a different view. So yeah, you can see here that basically the API is searching in exactly the same way as the front end. So now we've seen my amazing website. Let's have a look at the code. So just a quick look at the code. This is a drop wizard application. So this is Java, and yeah, it's pretty simple. So when I started this application just a moment ago, before you all came in, I ran this main method, and all this does here is just start a stub database, which we know exactly what planes it's going to have in it for our test assertions, and then we start the application. So the application, again, is pretty simple. We have a few resources, so the search resource, the contact seller resource, which is the one that has that takes the post request of the form that's been filled in, and also the email lead resource as well, which is the API that I showed. All of these resources here basically just rely on some database services, which again are pretty simple. So if I go to the plane service here, you can see pretty simply here, okay, select star from planes where blah blah blah. So that's basically how it's all working. So the question is, how do we test this? Oh, I should also mention as well that we have the static assets as well that are served, just the HTML over here. And also, yeah, some JavaScript and CSS and things like that. The point is, all of that stuff needs to be working for this site to work. So if we go to my homepage test, this seems really, really simple at first glance. So all we do is we load the homepage, and then we just check that the title is Planes for Sale, and that there is a search for Boeing planes and a search for Airbus planes button. And we don't click anything, we just load the homepage. That's all we're doing. But we are actually checking the HTML. So the way in which this test is working is this is starting up Selenium, which then uses Chrome, which is on my laptop, and loads the actual page fully end-to-end. So if I run this acceptance test, this hopefully will pop up super quick a browser, you'll see the home page, and then it will disappear and the test will pass. Cool. So that's worked. So the next thing is, you may have noticed that I've annotated this method, this class, with @monitor, which is part of atom4j. So this is really just a label, just saying this is good to be run in production. So one of the things that really needs to be considered, though, is if you do have a low traffic website and you start running these on loop, how are you going to filter out these events? So even a test as simple as this, still you have to think about the event issues that will propagate from it. So if I show this, so this is a browser-based acceptance test, and when we start Chrome here, we give it some options. And what I'm doing is I'm specifying that the user agent is acceptance tests as monitors. So that means that when we run the test, and in fact actually if we scroll down over here, you should be able to see the request coming in with the user agent as we mentioned. So how do we run this in production? It's quite simple. This artifact here, Planes for Sales site, is the actual website, and it has all the tests, just like any other Java project. And then we have this project over here, which is acceptance tests as monitors, which really is just another drop wizard application. And it just imports the tests that are generated by the other project. So you can see here, we've just got a main method, just in the same way as the other website. And we have we've created this object here, atom4j, which has some configuration over when to run it. So you can see here with test classes, I've just set up just one at the moment, the homepage monitor acceptance test. So if I run this now, so now I'm running the website and also the acceptance test as well. So you'll see that pop up from time to time. So let me have a look. So we can see that the site's available. And now if I go to this API here, you'll see. So this is basically the tests endpoint that's been exposed by atom4j, and it's just a JSON response which just tells you that the homepage monitor acceptance test is working as expected. And this can just be monitored in just the same way as anything else. So the next one to consider is the search. So if I go down to the search API test, so this one here, we have, for validating search, we have two different types of tests. So we've got the search acceptance test, which has not been labeled with @monitor, and this is relying on known planes in the database. So you'll see here that what this is doing is it's loading up the home page. It's going straight to the search results page, it's waiting for the plane to be visible, and then over here what we're doing is we're checking that the elements are all present and correct on the page. So this plane here, we know is going to be in the database because it's in the stub database that is running. So the acceptance tests have full control over the data that's there. So that means that you can write tests quite easily. Obviously, that's not going to work in production because you don't know what planes are going to be there. So the way that I've decided to do that is by creating a test which does kind of the same thing, but is less strict. So the idea here is that I don't know what plane is going to be there, but there should be at least one Boeing plane coming back on the search results. Because the data is going to be changing, I can't assert that the manufactured data is going to be one thing or another. You could possibly query it by an API, but this makes the test a little bit simpler in my mind. You can also possibly check that the model number contains a 7, because I'm pretty sure that every Boeing model has a 7 in it, with my expert plane knowledge there. So yeah, this is another thing that can be added to our configuration. So basically, by adding more classes to here that are annotated with monitor, we can then build up more and more test coverage. And in fact, we can actually, if I remove this altogether, it will actually just scan for all of the classes that have been annotated with that monitoring annotation. So instead of showing that one running end to end, I'm sure you can probably imagine the really big one here is the contact seller one. So this is really, everything leads up to this, and of course, your product owner is only going to really care about the email leads that are going through. So how do you test this without affecting real sellers? You don't want to be annoying people who have paid good money to upload their Boeing 777s for sale by just sending them a whole load of spam. So I think there are kind of two ways of doing this, and the first way is really considering how far do you want your events to propagate through the system. So we could write some code in our main website that will say, if this request has been generated by the tests, don't send the email out. That, to me, with my developer hat on, is a bit of a code smell, because you're then writing code in production for the tests, which is not great at all. So a way that we can kind of cheat this is by creating a plane with a special manufacturer. So you may have remembered that this search here just generates a URL to the manufacturer Boeing. Okay? There's nothing stopping me typing a different manufacturer. So why is that? I'll just restart that. Okay, so what I've done here is, when the app hopefully starts up, come on. Okay, so what I've done here is I've created a secret plane, and I've given the manufacturer a UUID. So you can find this if you happen to know the URL. You know, if this were made public, it would just be a plane that, where you would contact the seller, it would just go to a company-controlled email address, which could then be asserted by the tests. So for me, this is the best way to do it. But you've now got this test data that is now lurking in the production database. So at the moment, this is absolutely fine, because we know that the only way that people can explore it is by clicking on those two buttons. If the product owner comes along the next day and says, do you know what, actually I want to get rid of those buttons, I just want, you know, load all and just select them all, then suddenly this secret plane is going to be affecting the user experience. So there's no right or wrong. Sometimes you will want to stop events propagating so deep. Other times you'll want to try and hide data, or possibly annotate the data as well with some extra attributes to indicate that it is test. So this is really just a case-by-case decision. So the next thing to show is really how this can all work. So the interesting thing here is that running the Selenium tests I actually picked with a web browser was just because when we tried to do this years ago, this was really, really difficult, because you had to have a headless browser installed on a machine, and you had to have the drivers and so on and so forth. You know, with tools like Docker, this becomes easier and easier. So just a quick demo here, really, of everything all running all together. You can just basically run a Maven clean install here, which just builds everything. And then we just run a Docker compose build, and then that will build all of the images that are necessary, and then an up, and then that will run everything. So running the acceptance test will generate a lot of pop-ups annoyingly as well. I'll just wait for those to finish. Acceptance tests have been made a little bit slower by the fact that the pop-up kind of animates in and animates out again, which I did think about removing, but I liked it. Okay, so yeah, we've got multiple services here. So we've got Selenium Hub, which just takes the command to actually dispatch to multiple browsers. So there are people out there that are running, you know, farms of different web browsers with different versions for testing. And then we've got the actual site, and then we've got the monitoring as well. So these are just Docker images, just in exactly the same way. And then we also have the database as well. So if we now go up, so you'll see now when we go to the home page, hopefully when it all starts up, it will be running the tests, and we'll be seeing different planes as well, because it's a different database. It's not the same one. So if I go to the tests endpoint, it's too early. So this is one of the features of Atom4j. It will be positive and return a 200 response if the tests have not yet run. And then if we keep reloading that, so now under the hood, all of those acceptance tests are now passing, and we don't have the annoying pop-up because Chrome is running within one of the Docker containers. If we have a look at the logs here as well, we can see lots of activity. So yeah, you can see as well, we have a test listener here as well, which is indicating how many tests have run. Another feature as well, you may have noticed, we have a concept of categories as well. So you can actually separate the API tests from the browser tests as well. So this can also help, I think, with finding faults and finding issues. If you've got something that's just wrong with one part and that's broken, then you can kind of work out what's wrong with your incident response. Just another thing to show is the database that I'm using here. You'll see that this production data, of course, we've got the fake plane lurking in there, which you're not going to come across. Okay, so I will stop that. And back to the slides. Okay, so solving the test data and event issues. Can you hide the data? Can you mark it as test data? As I say, sometimes you won't want that data propagating through the system, and the same for the events as well. You might want to cut them short. You also, you'll need to talk to your downstream systems as well. How can we send you guys transactions that you process, but maybe not process in this way or process that way? You want to make it as real as possible, but of course, your domain is, your expertise, and so, only you guys really can actually answer the question as to how far you want these test transactions to go. A golden rule, though, is the monitoring real user and client activity is something that I said that has huge value. You want to always make sure that you are excluding your test transactions from stuff like this from monitoring real users. So a rather depressing story. When we went live with a feature, we switched it on, the button was there on the homepage, and we were all patting each other on the backs when we saw that the user activity was quite consistent. And we were like, oh, that's fantastic, people are already using it. And we realized that this user activity was very, very rhythmic every 5 minutes. And then we realized that it was our tests. And so when we updated the dashboard to filter that out, it flatlined. So that's just a bit of a depressing story, but the thing that's really important is that you'll need to make sure that you exclude it, because in some situations you could have a nasty situation where perhaps your tests are working, but then real users can't log in, and you're asserting the wrong thing, and you're working off the wrong assumption that the site's fine. So yeah, always exclude those. So I mentioned Prometheus as well. So at the moment, Atom4j doesn't support it, but it is on a branch. Atom4j is also on GitHub as well. So we have an issue for supporting Prometheus. I think we're going to do it, but it'd be really interesting. If any of you are interested in it, then do comment on the issue as well. It'd be really, really good to see how much support there is. And also, Atom4 Node is being considered just by the fact that my friend Anurag, who I wrote this with, is now working at a place that's Node. So yeah, that could be in the pipeline. So to conclude, it can have benefits. The cost benefit will depend on your domain. If you do it, do treat the tests as similar as possible to other tests. If they are, oh, they're other tests, that's what Joe does. He sits over there. I'm not sure about those. If they're like this, they'll just break, but break later on in the process. You want them to be the team. You want them to be owned by the team, because if they do break, the quicker you identify that they're broken, the quicker you can fix them. So as we've seen, a lot of the tools that are available now will really, really help with this. But the hardest problems for you to solve are going to be specific to your domain. So yeah, that's it. Thank you.